The Simultaneous Iterative Reconstruction technique, or SIRT, is, as its name implies, an iterative method that updates the reconstruction using all the available projection data simultaneously. The first thing to spot in the iteration formula of SIRT is the computation of a weighted projection difference. You can clearly see that W times V, which is a forward projection of the current solution, is subtracted from the measured data P. The result of this is then weighted by the diagonal matrix R, which contains the inverse row sums of the projection matrix. And this is basically the inverse of the length that each ray passes through the volume. Shorter rays thus have a higher contribution. And this weighting is required to guarantee convergence. In a second step, this weighted projection difference is back projected by multiplying it to the transpose of the projection matrix. And the result of this is then again weighted, this time with the inverse column sums of the projection matrix. Finally, this weighted back projection of the projection difference is then added to the current reconstruction. Now it can be proven that by following these update steps, the reconstruction volume V converges to a weighted least square solution where the weights are defined by the inverse row sums. Let us now look at the SIRT iteration formula again, but this time with an example. Here we see a sinogram of a 512 by 512 Shep-Logan phantom image taken with 180 parallel beam projections. We start by choosing an initial reconstruction volume V0, which is typically a blank image. This image is then forward projected, this time resulting in a blank sinogram. This is then subtracted from the measured data and weighed with the inverse row sums. The result of this is then back projected, weighed with the inverse column sums and used to compute V1. This process is then repeated, and you will see that by the end of the second iteration, the result will be improved quite a bit. And if we keep on iterating, we will eventually converge to a nice reconstruction.